an opposite. So what is my rule for an inverse? It's a reflection over which line? The y equals x. So if I have this, a line here, and I wanted to make its inverse, it would be a reflection over this line. I would take each one of these points and I would swap them out, which is the opposite that Hetzel was just saying. I would take that and I would swap it out, and then I would graph my new points. Now, we had a problem when we had a parabola, because your original function has to be a one-to-one. I don't know if you remember, way back we had this little worksheet that had the bubble thing on it when we drew inverses for your parabolas. Oh, probably like a few months ago now. But I gave you this little worksheet and we changed your calculator to show the bubble, and it showed where your inverses were, and then we did a draw inverse on your calculator to see if we had the right one. Now the problem with this is it has to pass a horizontal line test. It's a function. Sorry. Has to pass a vertical line test. It's a function. But it also has to pass a horizontal one to be a one-to-one. And we said way back when we did parabolas, we did your squaring function, it didn't pass a horizontal line test. So when we made its inverse, do you remember what we had to do? We had to say, don't use this part, right? We did either an increasing or we did a decreasing leg or arm, whatever you want to refer to it as. We had to restrict the domain on this. So, in other words, we said, use just this part of my parabola and then make its true inverse. We took this point, like say this point was 0, 2, we made it 2, 0, and we moved it over. And that would give us a true inverse. We had to restrict its domain. Well, we have the same problem with your sine curves. We have the same exact problem with your sine curves. Your sine and your cosine, they're continuous curves. Their period is 2 pi. They both are shifts of one another, so we're going to have to look at them separately. Now, if I graph your sine curve here, your basic sine curve, it's continuous. It keeps on going forever and ever. All of our inverses start in quadrant 1 because everybody's positive in quadrant 1. So our inverses are going to start in quadrant 1, and I'm going to follow my curve until I fail a horizontal line test. Doesn't this fail a horizontal line test miserably? So I follow. Whoops, I failed. I cut this off. So this is from 0 to 90. From 0 to 90, according to my circle, is quadrant 1, right? From 0 to 90. Now, I notice I'm okay if I go backwards. Did I fail yet? No, whoops, I just failed. So I went from 0 to 90, and I went from 0 to negative 90. What quadrant is from 0 to negative 90? 4. My curve is continuous. So this went 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. When I go backwards, this is my 1, this is my 4. Notice, I have one section that's positive, I have one section that's negative. Now, on my handy-dandy calculator, I'm going to put my calculator in degrees for a second, and I'm going to say the sine of 30 is what? Anybody remember the sine of 30? Well, I'm going to find the sine of 30. The sine of 30 is, whoops, my sine button didn't work. I think my board is so off. Nope, the sine of 30 is 1/2, right? The sine of 30. is 1/2. Now, what is the sign of negative 30? And doesn't that show me that here too on my graph? Okay. What is the sign of 150? Because isn't that this guy over here? Right? Now, watch what happens if I do second sign 1/2. Don't I have two angles? This angle and this angle. Isn't 30 and 150 both 1/2? So I'm going to say to your calculator, give me an angle whose sine is 1/2. Maybe. Here it goes. Second sign, this is my inverse symbol, 0.5. Tell me what angle, and it only gives me 30. It doesn't give me 150. So let's look at the graph for a second. Why does it only give me 30? Because it's what? 30 is my reference angle, but look at my little area that I can only look in. This is the only area that I could use for an inverse. It doesn't go, oh, I can't go over that way because I failed the horizontal line test. So I cannot get to this guy. If I ask for every angle that had a sine of 130, no restriction, I would get 30, I would 1/2, I would get 30, I would get 150, it would keep on going. But if I ask for the inverse, which does a restricted angle, it's only going to look right here. Now watch. What happens if I say, give me an angle whose sine is negative 0.5? Oh. You can do it on your calculator probably a lot easier than this calculator is working. Now what should it tell me? Negative 0.5. Negative 30. There it is. Your calculator does a true inverse. Oh, I also have one over, there's my negative 30, there's my negative 150, but it only gave me negative 30 because it can only look for a true inverse. If you remember back to when we looked for true inverses and we asked your calculator to do them, it only gave us true inverses. So the only parts that I can look at is right here. As soon as I fail that vertical line test, I can't use this anymore. A horizontal line test, I can't use this anymore. So, our goal is here to restrict our sine curve. Here's my restricted sine curve. My restricted sine curve says go from negative pi over 2 to positive pi over 2.
That's the domain, right?
That's the domain. Now, what's the range? Negative 1 to positive 1. Now, we learned when we do an inverse, we swap your x and your y's. This range will now swap to this domain. This domain will now swap to this range. Now here is why it's difficult to graph the inverse here. Normally, when we graph a line, it's your x-axis is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, your y-axis. And if we interchange the point 2, 4, it becomes 4, 2. We have no trouble graphing it. If we interchange this point is pi over 6, 1/2. If we interchange it, it's 1/2 pi over 6. I have to locate 1/2 now on my x-axis. And I can do it.
Bless you.
God bless. Pi is 3.14. Pi over 2 is 1.57, I think it is. 1.5 something. If I need to get to 1/2, this is 1.5. My 1/2 is probably over here somewhere. And my pi over 6, I got to divide this by 3.14. So it'll be like 0.5 something. It would be over here. So this is why I struggle with graphing these as well. By the time you invert your points and you find it, it's a reflection over the line y equals x. So it's, see, I can't draw these. This is why I gave them to you. So somewhere your line is getting to be over here somewhere. It's a squiggle line. I will not ask you to graph it because it means changing your x-axis and your y-axis. And we can absolutely do that because it's in radian measures. We can do that. But what I want you to make sure you know is this right here. Because when we look for restricted angles, when we do true inverses, we can only look in this section. And we always end up with one quadrant positive, which is for all of our functions, it's going to be quadrant 1. And then one of those quadrants will be negative. For sine, it happens to be negative in quadrant 4. So if I say to you, find me an angle inverse whose sine is radical 3 over 2, what quadrant would you find this in? I'm using an inverse function. What quadrant is sine positive on a restricted sign? What quadrant are we positive? 1. If I say this, restricted, and I put a negative here, what quadrant am I going to look at? 4. Whenever I use inverse notation, I have to use my restricted domain. So my sine, when I go to map out my triangle, will be positive in 1, will be negative in 4. And when I find this, y over r, I still get my special little triangles. If this is 30, my positive angle becomes pi over 6. Whoops, this is a y. I did it backwards. So pi over 3. My other guy down here has to be negative pi over 3. That's going the opposite way because my domain only goes from negative 90 to positive 90. Negative pi over 2 to positive pi over 2. So you see what we're looking at? I'm not going to ask you to graph it. I gave you the graph on the bottom. I gave you the graph on this page. This is the graph. As if I took that sine curve, here was my sine curve in here. I'm really bad at drawing. And if you kind of make some kind of a, like here's your reflection line in here. Can you see it? Can you kind of see your reflection line? I really stink at drawing. But what I want you to remember is that our original sine curve, when we restrict it, is from negative pi over 2 to positive pi over 2. Okay. When we switch them around, your domain becomes your range becomes your domain. Okay? Now, the cosine works a little bit different. It is, again, a continuous curve. However, your cosine curve says, I don't know if you have a spot to draw it. Your cosine curve says start at 1. And come back. Right? Isn't this my cosine curve? Now, we always use quadrant 1 because everybody's positive in quadrant 1. So I'm going to start here and go down. Could I ever back up and pass a horizontal line test? Nope. So I got to cut it off right here. Just follow me, okay, guys? Now, I'm going to travel until I fail a horizontal line test again. Cut that off. Do I notice one of my sections is positive, one of my sections is negative? So this is my pi over 2. This is my pi. What quadrant am I positive in? 1. What quadrant am I negative in? 2. So a restricted cosine curve goes from 0 to pi. If you visualize your curves, you don't even have to memorize this. you visualize your curves, just start your curves. You can't go backwards. You can't fail a horizontal line test. So start everybody in quadrant 1 until you fail a horizontal line test. So now it's the same kind of concept. If I say to you, find me a restricted angle whose cosine is negative 1/2, what quadrant will this be in? Quadrant 2. So I will drop a triangle in quadrant 2. I will label my x over my r. There's my 60. So this is a pi over 3. So if I chart this angle, that will be 2 pi over 3, or 120 degrees. Now, your calculator again does all your restricted angles. So if I say second cosine, negative 0.5, it will come back and say, oh, that's angle 120. Your calculator only does your restricted inverse because it has to do a true inverse. It can't find two angles at the same time. We have more angles that have a 120, don't we? That have a negative 1/2. We have angles down here that have negative 1/2. But all I want is my restricted one. So only 2 quadrants are going to have that. And again, my range is -1 to +1. So when you flip these around, you take these domain in your range for your inverse. Your range will now become what your domain was, and your domain will now become what your range was. And again, if I took any point and I had to flip it around, I'm going to make an inverse using that, and it's going to be a reflection over the y equals x. Okay, so here's my part from 0 to pi. This is pi over 2, this is quadrant 1, this is quadrant 2. I just wanted to show you the whole curve so we could see where we were going. That's key to the whole thing. What 2 quadrants should I use? And everybody's positive in quadrant 1. This makes sense, right? Now, your tangent curve is kind of a nice little surprise because your tangent curve has its own boundary. The tangent curve says you can't use pi over 2, and you can't use negative pi over 2. So you have to be right in between here. So then I do another section, n pi over 2. Remember, it's the n pi over 2 odd, guys. I do another one. I do another one. So if I'm starting in quadrant 1, and I'm making sure I don't fail a horizontal line test, I'm in quadrant 1, my boundaries don't let me go out there, they just let me come back here. So what quadrants am I using? 1 and what? What's before 1? If I go down this way. 4. So isn't it similar to your sine one? Because if I go to this next section, whoops, failed the horizontal line test everywhere I turn. So tangent is next. Tangent has its own little boundary. Period is pi, so it works out perfectly. I have one positive, I have one negative. Now the only difference from your sine curve is that you cannot use pi over 2. So instead of being a hard bracket, we're just going to be a soft bracket. And again, I'm quadrant 1 when it's positive, quadrant 4 when it's negative. The one thing you have to remember is, if you're in quadrant 4, you've got a negative angle. Don't come all the way around from here to find your angle. Give me a negative angle. Your range would be negative infinity to infinity, absolutely. And your tangent curve, that's probably the only one I can draw, goes like this. It comes like this. See the reflection over the y equals x? So it comes out this way. So when Hetzel says it has a range now of negative infinity to positive infinity, its new domain will be its range, negative infinity to positive infinity. But I don't want you to worry about the new domain. I want you to worry about the restricted one. Okay? On the original tangent curve. So when we take the inverse, that becomes its new domain. See the green line? That would be the inverse of the tangent function. That one I can actually draw. The other ones I have a bad eye. This one I can draw. And actually this one you can see. Can't you see the reflection over the line y equals x a lot better than having that little piece of curve? Okay. Why do we use all this? To find our inverse functions. We look for a restriction. We drop the triangle in the restricted parts, and then we solve like we normally solve. So let's take a look at something. So this guy tells me, now, to show an inverse, you have a number of ways. You can say arc cosine, arc sine, arc tangent, anything that you want to find. You can say sine -1, cosine -1, tangent -1. It could be a capital letter, it could be a small letter. As soon as you see this, it's saying, find me an angle whose restricted domain, you need the restricted domain, has the sine of whatever. Sine equal to, cosine equal to, whatever. But it has to be in the restricted inverse domain. So as soon as I see arc cosine, this tells me I got an inverse. So to me, as soon as I see cosine, I sketch my cosine curve because I don't memorize these things. I sketch my cosine curve. And I say, oh, start in the 1, quadrant 1, don't go backwards. Keep on going, there's the 90. Oh, stop right there, there's the 180. What quadrant am I in? 1 and 2. So it could be here, or it could be here. This guy's positive, this guy's negative. Do I want a positive or a negative? Positive. So I don't want this part, I just want this. And then I label X over R. My special triangle. What reference angle is this? 1, radical 2. 45, which is pi over 4. Now, if I ask my calculator to find it, it would say, I have it in degrees, second cosine, and you would put in 1 divided by maybe. You would have to put in divide by, because apparently I can't. There it goes. Radical 2. And it would say, yep, yeah, 45-degree angle. Now, notice your other positive for your cosine was down here, but we didn't look in quadrant 4, right? We only looked at 1 and 2. So question, lady? Alicia? Did you have the same question?
I don't know. I don't know if
Because this is an inverse, we draw out our curve, we stop it from failing a horizontal line test. So we can only look from here to here. In quadrant 1 it's positive, because this is 180. So this is quadrant 2, it's negative. I don't want the negative, I want the positive.
And then how do you fill it in with that?
Well, that's what we normally do.
Oh.
Cosine x over r.
Oh, I see.
Yeah. That's all.
I was going to say, can you leave that in degrees?
I usually use radians. Putting your calculator in radians is hard because it does 3.14 divided by 4. So you don't really want to leave your calculator in radians. Okay, so let's try another one. So, arc sine tells me restricted sign. So I can't remember where it goes, so I draw a sine curve. Here's my sine curve. You guys should know those curves by now, right? So I start in quadrant 1. I'm moving along. Whoops, I failed. I go backwards. Whoops, I failed. What quadrants am I looking in? 1 and what comes before 1? 4. This is my restricted domain. Negative pi over 2 to positive pi over 2. So you don't have to memorize. You just have to get used to looking at your curve and stopping it before it fails a horizontal line test. So in 1 and 4, 1 is positive, 4 is negative. Which one do I want if I want the negative? I want 4, so now I label y over r. There's my 2, there's my 1. What angle am I? What reference angle am I? 30. Now, I don't want to start over here and come around. That's out of my domain. My domain only can go from here to here. So I'm going to go down here, and what's my answer going to be? Negative 30 degrees or negative pi over 6. So it can only be from a negative 90 to a positive 90. And only in those two places. So if you notice, sine and tangent use the same ones, with the exception of the exact 90 for tangent. And cosine uses 1 and 2, because it starts at the very top and slides all the way down into quadrant 2. So whenever you see the word arc, restricted. Negative 1s, restricted. If I just said the cosine of this angle is 1/2, then positive 1/2 is both of these. But if I say cosine negative 1/2, then I want to restrict it. Then I only want the quadrant 1 angle. See the difference? Your true inverses give you a restriction. They can't fail a horizontal line test.